Hello and welcome to section 2.2b, Polynomial Functions of Higher Degree. In this video, if you have any questions, please bring them to class so that we can talk about them. So you should be taking the notes, you should be writing all of this down. And so we're going to go through and determine the number of zeros, which is the number of places it crosses the x-axis, and the number of relative maximums and minimums. So when we're looking at this first example here, I will go ahead and tell you that the highest degree is the number of possible zeros there are. And so we could have the highest degree is 2, so that means there's 2 places the graph could cross the x-axis. Does not mean that it will cross the x-axis there. It just means that's the possibility of the number of crossing the x-axis. And so if you remember that this is a parabola, I will graph an upside down parabola because it's negative x squared. And so you can look at it and maybe you can figure out the number of relative maximum minimums, and so it is increasing, and then all of a sudden it decreases, so it looks like there is one relative maximum and minimum. And so then when we move on here, we have a degree of 3, so that means we have a possibility of 3 zeros. And so I'm going to sketch a quick cubic function that would look something like this. You can see that if I drew a line, if I drew the x-axis like right here, that it would cross 3 times. And so then maybe you can figure out that I'm increasing to decreasing there. Looks like there's one maximum. Then I'm decreasing to increasing. Looks like I have one minimum. And so there are 2 relative maximums and minimums in this case. And so you need to kind of keep in mind whenever you see these, the square, the cube, the fourth function, what these shapes look like. And so in the fourth function, you'll notice we have a power of 4, so there's a possibility of 4 zeros. And so this is a kind of a W-shaped graph. Since it's negative, it's actually going to look more like an M. Probably something like that. And if I had my x-axis going through about right here, you would notice that it could cross the graph 4 times. Now, it doesn't mean that it's going to cross 4 times, it just means there's a possibility. But when you look at this graph, you'll see that it's increasing to here, and then it starts decreasing, so there's one maximum. Then from there, it's decreasing now to increasing, so there's a minimum. And then it looks like there's an increasing to decreasing, so there's a possibility of 3 relative maximum minimums. Now, maybe at this point you can see a pattern between these, and you could do this last one. If you want to pause it before I give away the answer, go ahead and pause it and try it on your own, and then I will give away the answer. So here's the answer to D. There are possibility of 10 real zeros. It could cross 10 times, cross the x-axis 10 times, and the number of maximums and minimums looks like there would be 9. And you'll notice that the pattern for relative maximum and minimums is always 1 less than the number of zeros. Moving along, we're going to talk about repeated zeros, and this is the reason why there's the possibility of not having it cross that many times, is that if I had a graph, for example, that is an odd, so x minus a cubed or something like that, it will cross the graph at a. If it is an even function, then it should just touch when we have, so we're kind of talking about multiplicity and things showing up more than once. And so I'm going to give you a quick little example. It says for the example x minus 3 squared, well, if I go to x minus 3 squared and graph it, here's the function for the squared. And so x minus 3 squared, where the whole thing is squared, you can see that the graph comes down and just touches at x minus 3. And so that's what we're talking about when we're talking about repeated solutions in this case, is that or when we have factors and the multiplicity, this graph is a multiplicity of 2, it's not going to cross, it's just going to come down and touch. Well, how does that work for x cubed? Well, if I go to x cubed, in my x cubed function, well, according to the repeated zeros example at the top, this should cross at x equals 3 and not be with it being a multiplicity, it doesn't cross anymore, it just touches at x equals 3, and so we end up with just having 1 0 at x equals 3 because it's cubed, and this is basically what this whole part is talking about up here. So please copy it down, please make sure you have it. If you have any questions, please come in and ask. So then we're going to talk about finding all the real zeros of this function down here, and with this function we can, we're basically trying to figure out where it's crossing the x-axis, so I'm going to get my calculator out and graph it. Got to get rid of this one first. And you can see that when I graph this one, that even though it's supposed to cross the x-axis 5 times, it looks like it's only crossing it 3 times. And when I look at this, it should have 4 relative maximum minimums. Well, this is where the repeated zeros and things like that. So there must be some factors in here that cause it just to cross the x-axis and not actually give us more than give us up to 5 zeros. There must be like some imaginary solutions or something like that. And so now what I'm going to do is I'm going to go ahead and find the zeros of this using my second trace button, which is second calculate, and find the zeros. And you should be practicing this at home, so you should have your calculator out and actually be doing these problems to get the practice, because you're going to be expected to do this, and just watching it doesn't mean that you really understand. So 1 0 is this solution right here. Let's get another one. And so I'm going second trace, and I'm finding my zeros. And again, you should be doing all of these too at home. You shouldn't just be sitting here watching. This isn't passive learning here. You guys need to be watching this stuff. You need to be doing this stuff too. So when I find this 0, here's another one. And so then I go second trace, and I'm going to find my third 0. And so I need to be below the x-axis. I need to be above the x-axis, and then try to guess as close as I can to it. And so here are my 3 zeros for this function, and I could have 5, but I only have 3. Probably because there's some imaginary solutions, or there's a multiplicity. If I factored this, I might find it. So 1 0 is negative 1.86 and 0. The other one is negative 0.25 and 0. And the third one, even though this guy right here doesn't look like y equals 0, look at it's times 10 to the negative 12. Think about 12 zeros in front of that. That's a pretty small number. So we're going to call it 0. And so those are my 3 zeros for this function. And so why are there only 3? Maybe because there's factors that repeat, like we had in the example up above where x minus 3 squared repeated, or x minus 3 cubed, it repeated 3 times. Maybe that happened. Maybe there's some imaginary roots, something like that. And so that's kind of where we're headed with these guys. So then moving along, we're going to actually ask you to find the solution. Given the solutions, find the function. And there's a reason there's many correct solutions. We'll talk about that in just a second. So the first thing I need to do is find out the factors, what the factors look like. I need them in binomial form. So I'm going to write these as what they are: x minus 1/2, x equals 3, and x equals 3. So those are what my solutions are written as. Now if I kind of work backwards, I want to find out what the function equals 0. I'm not just going to add a half. I'm going to actually multiply by 2 on both sides. So then I get 2x equals negative 1. If I add 1 across the equal sign, I get 2x plus 1 equals 0. So that is one of my factors that I'm going to use for my function. If I subtract 3 across the equal sign on both of these guys, you'll see that I get x minus 3 equals 0 for both of them. And so by doing this, this gives me the zeros functions that I needed, and basically the factors that I'm going to use to multiply this together. So for my function, I'm going to set it up that my function of x is going to equal 2x plus 1 times x minus 3. And since I've got 2 of them, I'm just going to write it as squared. Multiplicity of 2. And then up above here, you see there are many correct solutions, because remember, when we're writing these, we need to keep in check the fact that there might be a stretch or compression in this graph. And so I have to put this a value. Now the only way I'm going to be able to find the a value is if I have an ordered pair that the graph goes through. Since they did not give me an ordered pair, that's where the many correct answers come from. That a could be any number, and it could be, you know, it could be stretched, could be compressed, all kinds of different things. So really this a is just kind of window dressing. It's just going to kind of sit there with the problem, and we're not going to do much with it. It's just going to stay there for in case we get an ordered pair that we could plug in and find what the actual stretch or compression is. So now all the work that I have to do is multiplying this stuff together. Well, I'm going to leave the 2x plus 1 alone, and I'm going to use the box method to multiply x minus 3 together. And so I've got x minus 3, and when I do that, I get x squared minus 3x plus 9. So this factor is x squared minus 6x plus 9. And then now I get to do the fireworks, and I get to multiply 2x times all three terms, which I will do that right now. So f of x will equal a times, if I take 2x times each of these terms, I get 2x cubed minus 12x plus 18, 12x squared plus 18x, and then I'm going to multiply 1 times all of these terms, and just to kind of make my life a little bit easier, I'm going to move over 1, because if you look, if I take 1 times x squared, it's an x squared, so I'm going to line it up with the x squared terms. And this is just, you don't have to do this, you could write out one big line if you like, and then combine your like terms, but I like to do this because now if I add straight down in this problem, I have all my like terms together, and so then I can have my solution without having to hunt and find and maybe miss one and go back and work a little harder to find it. So there's no other x cubed, so 2x cubed is part of my solution. If I combine together 12x squared and 1x squared, I have an 11x squared. If I have 18 minus 6, I have 12x, and then plus 9. So this is my final solution. This is what I was looking for. But the problem is that there are many solutions is because we don't have an x or a y value to plug in to actually get what the a value is, the stretch or compression that could exist, or maybe even a reflection across the x-axis. We don't know. So moving along, the final example of today, we are going to graph this function by hand, and we're going to include as many important points as we can get. So first thing I'm going to do is, I know that this thing has could have 4 zeros. Could have 4 zeros. Could have 4 zeros. Relative max and min. Could be 3 of them. I know this is a W shape, and I know the graph shape is something like that because it's a fourth. And this is just from graphing them, and if you guys need to get used to knowing these, like I said in the very first example. So now I'm going to go ahead and find the zeros of this function. So the original function is this, that is 3x to the fourth minus 4x cubed. If I set f of x equal to 0, I'm going to say 3x to the fourth minus 4x cubed. You'll notice that I have an x cubed in common, so I'm going to do a little factoring, factor out an x cubed, and I'm left with 3x minus 4. So now using my zero product property, I can separate these factors and say x cubed equals 0 and 3x minus 4 equals 0. Well, you'll notice I must have a multiplicity of 3 for x equals 0. So now I have an ordered pair of 0, 0. That is one of my zeros of the function. And over here, when I solve, I get x equals 4/3, which gives me 4/3 and 0 as another place on my graph. So I'm going to plot 0, 0, and I'm also going to plot 4/3, which is approximately there. So now I'm going to go ahead to get the rest of my graph. I'm going to go ahead and set up a t-table and plug in some values around these points. Well, I'm going to go -1. I have 0, 0. I'm going to put 1 in there, and I have 4/3. And then I have 2 also as part of my solutions. I know that 4/3 is 0. So plugging in these values, if I plug in -1 into the original function, and my original function is right here, so plugging in -1, that turns it into a +1, so I get 3. And then putting in -1 here, I get -1, but it's 3 plus 4, which would give me 7. Down here at 1, if I put 1 in, I get +3 minus 4. So I have -1 for that one. And then when I plug in 2, I'm going to have to do a little work. 2, 4, 8, 16. I just multiplied that. So 16 times 3 is 48. And then I'm going to do 2, 4, 8, just cubed 2. 8 times -4 is 32. So when I subtract those, it looks like I get 16. Well, 16 doesn't fit on my graph, but I'm still going to plot as best I can. At -1, I'm up here at +7, which should be like right there. At 1, I'm at -1, so I'm down here. And then at 2, I'm up at +16, way up at the top, and I don't have enough room on my graph. But remember now, I said this was a W-shaped graph, so we don't want it to look like a parabola when I do this. So it's going to be a little bit more of a challenge. I also know, since it's a W-shaped graph, that it is going to have it open both ends up, and so that's kind of where we're going with this. So this should be a pretty good picture of what we were talking about. And so if you have any questions on any of these examples that I've given you in this section, please come to class prepared to ask those questions.